Right, so I just wanted to put them all together in one place and just do a overall recap. So I hope this will be a short video. So metallic structures are giant, ionic structures are giant, giant covalent structures are also giant. Only only small quantum molecules are small. Okay, they're not giant. Right, the structure for metallic is, you draw those 12 ions. So minimum always 12, and you write down the metal ion inside, and you have delocalized electrons around the structure. Okay, so you have electrons around the structure. Okay, ionic structure are the ones where you draw the square brackets. So from Na, that would be plus, and then let's have okay, it's too big, so like Na. Let me do Mg, because we didn't do Mg before, I think. So Mg, and it needs to lose 2, right? So it becomes a 2 plus chart. And let's do oxygen, so magnesium oxide. So the oxygen has 6 electrons in total originally. It gains 2 from the one lost by the magnesium, so it becomes 2 minus. Okay, so MgO is magnesium oxide is MgO, and remember the crisscross thing. So it is magnesium is Mg2 plus, oxygen is 2 minus. You do crisscross, you get Mg2O2, and you can simplify this just like maths. It becomes Mg, so MgO. Okay, that's it. Right, I mean like the formula name for magnesium oxide, it's MgO. Okay, not Mg2O2, because it can be simplified, so it will be MgO. So for one magnesium ion, you need only one oxide ion. Okay, and if you look at the magnesium needs to lose 2, oxygen needs to gain 2, and that's why one oxygen is enough for one magnesium. Right, small covalent structures. These are the Venn diagrams. So then let me do iodine. Okay, so iodine has 7 electrons in its outer shell. So so the 7th one will be inside. And then the second one is here. So we have 7 dots, 7 crosses, because each iodine has 7 electrons only. And then they're shared in a way so that they each have 8. And yeah, and you still have 7 dots and 7 crosses. Okay, so that's a neutral iodine molecule. Okay, and it's small. And giant covalent structures for diamond, as we did just a while ago. So you've got carbon bonded to 4 other carbon, and then better to draw 3 layers at least. So they're all carbons. So each carbon is bonded to 4 others. Graphite, you have those layers. Each layer of graphite is called a graphene. Graphenes are very strong, very, very strong. So in graphite, each carbon is bonded to 3 others, and the fourth so each carbon is bonded to 3 other carbon atoms, and but carbon is capable of making up to 4 bonds, right? So if carbon is bonded to 3 other carbon atoms, that means 3 electrons are busy. The 4th one is free, because each carbon, remember, like carbon is in group 4, it has 4 electrons. So this one can get involved in bonding, this one gets involved in bonding, that one gets involved in bonding. So so this one will be free, this one here will be free, and that is the one that is actually delocalized in the structure. Okay, so you've got delocalized electrons in the structure. All right, so that's the structure done for all of them. Now properties. Metallic, they have high melting point, and also boiling point, and it also have high melting point, high boiling point. Giant covalent structures also have high melting point, high boiling point. Okay, so they're 3 are giant, and they also have high melting point, high boiling point, although for slightly different reasons, because here in metallic and ionic, it's because of strong electrostatic forces, okay, of attraction between opposite charges. Here it's also the same, but just remember in metallic structure, it's between the positive metal ion and the negative electrons. In ionic structure, it's between the positive metal ion and the negative non-metal ion. Okay, and here in giant covalent structures, it's got nothing to do with electrostatic forces because you do not have opposite charge. Okay, diamond here is neutral, and carbon and then graphite only have delocalized electrons, so just negative charge. Okay, so here it's high because of it's a giant lattice or structure, many covalent bonds, because it's a giant, so there will be many covalent bonds. One covalent bond is already very, very strong, and if you have many covalent bonds, that's like too much energy is required, so a lot of energy required. Okay, horrible writing. To break those bonds. Okay, horrible writing, but giant lattice, many covalent bonds, a lot of energy is required to break those bonds. Okay, and then in small covalent structures, they are different because they have low. Okay, let me use another. They have low melting point, boiling point, and please remember, it's not that you're breaking the covalent bonds, you're breaking the weak one. You're overcoming the weak van der Waals forces. So because of weak forces of attraction, okay, and that is between the molecules. So you have chlorine molecules. So the weak forces is between them. Okay, so these are the weak forces. That is the one that gets overcome. So it's easy to overcome weak forces of attraction. Okay, and electricity. Let's use what color? Pink. So electricity, metallic structures conduct electricity because their electrons, delocalized electrons, okay, free to move around. Ionic structure. In solid state, although you have charge, you have positive ions, negative ions, but in solid state they're not free to move around, so they do not conduct electricity, but they do in molten or aqueous state. Okay, they do because you have positive ions, negative ions, free to move. They do not conduct electricity because they're neutral, so they will not conduct electricity. Diamond also does not have any charge that is free to move around. It doesn't have any charge to begin with, so it doesn't conduct electricity. Graphite has delocalized electrons. Okay, it has delocalized electrons that are free to move around. Okay, do not just write electrons, you must write delocalized electrons. Okay, and that's about it. So in 10 minutes we have recapped all of metallic, ionic, small covalent and giant covalent, and in addition you just need to know how to explain the metallic structure, ionic structure, small covalent structures and giant covalent structures. You need to know the differences between diamond and graphite. In diamond, each carbon is bonded to 4 others, and it's a hard structure. In graphite, each carbon is bonded to 3 others, and the fourth one is delocalized. Delocalized around the structure. And diamond is tetrahedral, graphite is in layers. Diamond is hard, graphite is slippery. Okay, I hope that's all. I hope you can do well. Please try exam questions, and it should help you. I will try to go through some, but that's it. We've done the bonding topic, the whole bonding topic. That's good.